Okay, tonight we're looking at section 1.3, measuring and constructing angles. The two objectives are to 1, name and classify angles, and 2, measure and construct angles and angle bisectors. Again, there's your vocabulary. Write it down as we get along. All right, so a transit is a tool for measuring angles. It consists of a telescope that swivels horizontally and vertically. Using a transit, a surveyor can measure the angle formed by his or her location and two distant points. So an angle, first definition, is a figure formed by two rays or sides with a common endpoint. Next definition is a vertex. A vertex is the point of an angle. So looking at this is the vertex, that little point. The whole thing is an angle. So an angle consists of two sides or rays and a vertex. The plural form of vertex is vertices. You can make an angle several ways. You can name it by its vertex. Please write all three of these down. You can name it by the vertex, by a point on each ray and the vertex. You'll see this in the next one. Or by a number. So here is an example of an angle. So first let's get these other definition words down. The first buzzword is interior of an angle. The interior of an angle is the set of all points between the sides. So this little yellowish, whitish colored shaded area, this is an interior. Kind of makes sense that it's named the interior and this is named the exterior. So the exterior of an angle is the set of all points outside the angle. So now let's name the angles, angle names. So to name this angle, again, the first way was to name it by its vertex. So I could call it angle R. Angle R would be an appropriate name for this angle. Or you could call it by its side points and the vertex. SRT or TRS. Notice I put my R in the middle. I start at the sides, I go to the vertex, and then the other side. You have to go in order like a connect the dots. If I named it angle RST, that means I go R to S to T. That would be this angle. That is not the angle we're looking at. You have to use the correct way. So you have to name SRT and TRS. The safest way to get this correct is just use the angle. Use the angle vertex. When there's only one angle, you can use the vertex. Or this is numbered angle 1 for us. So you can call it angle 1 or angle R or SRT or TRS. Because down here, notice, you cannot name an angle just by its vertex if the point is the vertex of more than one angle. In this case, you must use all 3 points to name the angle, and the middle point is always the vertex. So if I drew another line here with a point P, if I wrote angle R as this angle right here, I wouldn't know what angle you're talking about. R goes with this angle and this angle. So if I'm going to name this yellow angle, I either have to use angle 1, because the 1's been given, or angle SRT, TRS, and then so this black shaded in angle, I have to either call PRS or SRP. When there's two angles with the same vertex, R touches both, you have to use at least 3 points to name it. All right, so a surveyor recorded the angles formed by a transit, point A. So point A is where the transit was, and 3 distant points, B, C, and D. Name the 3 angles. So there are 3 angles kind of happening. There's these 2 small ones, and then there's this big one. These are all angles. This is the small angle, this is a small angle, and then this is the angle that the 2 add up together. So let's start with first this little one. To name that little one, I can either call it angle BAC or angle CAB. Notice BAC goes B, connect the dots, BAC. Angle CAB is CAB. Same angle, no matter whether you go left to right or right to left. Okay, so now let's do the other angle, this other small angle. Again, I can do angle CAD or angle DAC. Same thing as the other one. I can name it left to right or right to left. Now I'm going to name this big angle, the angle that the two make up together. Again, an angle consists of two sides and a vertex. So here I had two sides and a vertex, two sides and a vertex. So now I've got two sides and a vertex. So I'm going to name it angle BAD or angle DAB. Okay, write the different ways you can name the angles. Again, we've got just a story problem, like a picture problem. A surveyor, we've got these two small angles, angle 1 and 2, and then we've got this big angle. So again, if you wrote angle T, I would not know which one you're talking about. T corresponds to this angle here, and this angle here. So first I'm going to address the small angle number 1. So I can call this angle 1 or angle QTR or angle RTQ. Those three right here name just this angle, all three of those. Angle 1 because of the numbers given, angle QTR or RTQ. So likewise with angle 2, I can call it angle 2, angle RTS, angle STR, and either three of those would be correct. Now for the last one, the big angle that makes up the whole two, I cannot use a number. A number was not given to me for the two of these. If they wrote over here that this was 3, then you could do that, but that's not given to you. So you cannot assume. So to name that, I'm going to go angle QTS or angle STQ. All right, so our next definition is measure, and that's our second buzzword. The measure is the degree from one side to the other. So here's an angle. When I measure from this side to this side, this is going to form a measure. I measure from side to side. And that measure is going to be in terms of degree. A degree is something that you measure angles with, or circles. Since there are 360 degrees in a circle, 1 degree is 1/360th of a circle. So this will make more sense as we see more problems worked out. So go ahead and get that down in your definitions, please. So then our protractor postulate down here. Given that AB is a line and O is on AB, so let's draw kind of an example out. Here's AB, it's a line, and there's O, it's on it. All the rays that can be drawn from O, so this is a ray, this could be a ray, or this could be a ray, can be put into a 1-to-1 correspondence with the real numbers from 0 to 180. So in the next slide, you're going to see what a protractor looks like, and that'll make a little more sense, but that is the protractor postulate. All right, you can use the protractor postulate to help you classify angles by their measure. The measure of an angle is the absolute value of the difference of the real numbers that the ray corresponds with on the protractor. So what that means is I start here and I look at this angle, COA. This angle is comprised of these degrees. So I start here at 0. If I start at this black side of A, I go up 10, 20, 30, 40, 45 until I get to the red. So this angle would be 45 degrees. This is not an example you need to have down yet, so don't worry about that. Now to go from angle A, or side A, all the way to D. So angle AOD, I'm going up 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, at 115. So from here to there, I've got 115. So what I did is you could subtract it or just measure it. So to find this angle, DC, you would have to subtract. So you're going to take 115 minus the 45 and subtract that. These are the 4 different types of angles. These are going to be very common. You will see these probably until your semester of geometry ends. The first one is called an acute angle. It measures between 0 and 90. The next one is a right angle. It only measures 90 degrees. So notice the difference between an acute angle. An acute angle can be anything from something so small that it's only got a 5 degree or something almost close to a 90 degree, but it's 89. So this would be an acute angle, and this would be an acute angle. Any angle that has a measure between 0 and 90 is an acute angle. There is only one right angle, and it has to measure 90 degrees. This little box indicates that it's 90 degrees. Third one is an obtuse angle. It measures between 90 and 180. So similar with the acute ones. Obtuse, this one looks like it would be about 145. That's not important right now. But an obtuse angle can measure anywhere from 91 degrees to 180. Next, we have the straight angle. A straight angle, similar to the 90, is there's only one straight angle, and that is when it measures 180 degrees. If it does not measure 180 degrees, then it is not a straight angle. Okay, so for example 3, we are going to find the measure of each angle and then classify each angle as acute, right, or obtuse. So first I'm going to look at WXV. So here's angle WXV. So I'm going to look at this protractor. I'm starting here at 0. So I start here at 0, and I'm going to use the inside little circle, inside half circle. Notice this one goes from 0 starting on the right side. So I'm going to start from 0. If I started over here, I would use the outside and count by zeros. So since I'm measuring this angle, I don't stop here at 150. It wouldn't make sense to say this is a 150 degree angle. So I start at 0 since I'm coming from this side, and I stop at 30. So angle WXV is 30 degrees. For B, they want me to look at ZXW. So here, it doesn't start on an edge. So I have to figure out what these measures are and then subtract them. So I need to subtract my W information and my Z information and find the absolute value. So let's look at W. Let's start on this side now. Since I'm starting on the left, I'm going to use the outside of the edge. So I'm going to use all the way here. The W goes all the way over to 150. Now I'm going to look at my Z. My Z goes up, starting from the left again, all the way to 50. So I do the subtraction, I get absolute value of 100. Absolute value of a positive number is just that number. So the measure of angle ZXW is 100 degrees. Okay, your next definition is congruent angles. Congruent angles are just angles that have the same measure. So if two angles both have the same measure, then they're congruent. So in the diagram down below, down here, measure of angle ABC equals the measure of angle DEF. So you can write angle ABC is congruent to angle DEF. This is read as angle ABC is congruent to angle DEF. Again, the congruent sign, this should be familiar by now. Arc marks are similar to the tick marks. So these little red arc marks show that angles are congruent. So if I see two angles and they're both have the same arc mark, then they're the same. And then secondly, the angle addition postulate is very similar to the segment addition postulate that you learned in the previous lesson. On the next slide, we're going to see an angle addition postulate. All right, so here's the angle addition postulate. If S is in the interior of PQR, so here's angle PQR, and S is in the interior. Again, this is the interior of the angle. This would be the exterior. They tell us S is in the interior. So the two angles that created by the S will add up together to be the whole angle. So what that means is like this little red angle added with this little blue angle will equal PQR. Okay, so let's do this example. Example 4. Measure of angle DEG and measure of angle DEF are given. DEG is 115 and DEF is 48. So I'm going to go ahead and mark on my diagram. I suggest you do the same. So DEF is given us to be 48 degrees and DEG is 115. The way I'm going to mark this is I'm going to start here at D and draw an arc mark all the way over here and label it 115. This mark that I've drawn from this side to this side, when I write my number there, it tells me that this is the angle degree of the whole angle. Okay, so angle addition tells us that since F is in the interior of angle DEG, the measure of angle DEG, rewrite that smaller. So DEG equals DEF plus FEG. So I'm just going to sub in what they've told me, what everything equals. They told me DEG equals 115, and they told me DEF equals 48, and they did not tell me FEG. This is just a one-step operation. To find FEG, to get FEG alone, I'm going to subtract 48 from both sides. When I do that, I find FEG equals 67 degrees. Okay, our last buzzword and your last definition for this note is angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So please write this down with this diagram. JK bisects angle LJM. Thus, LKJ is congruent to KJM. So this was the given angle. This blue angle was given to us to be the angle, the main angle. This red ray is the bisector. And since it's bisecting an angle, we call it an angle bisector. So this blue gets cut up into two green pieces by this red piece. So where the blue comes to the red, this is going to be equal to this other blue goes to the red. Okay, so we have a problem where they give us the bisector and they tell us JKM is given to us along with MKO. So because KM is the bisector, I know JKM is congruent to MKL. So I'm going to draw my arc marks. There. So JKM equals MKL. So again, I'm just doing like I did in the last example, plugging in what they give for us and then finding what they're asking. Okay, I'm going to go ahead and solve for my x variable. I'm going to go ahead and subtract 6 from both sides. I get 4x equals 7x minus 18. Subtract 7x from both sides. I get negative 3x equals negative 18. Divide both sides by negative 3. I get x equals 6. So my variable x equals 6, but that's not really what they're asking for. They want us to find the measure of angle JKM. So since JKM equaled 4x plus 6, I'm just now going to take my 6 and plug it in for my x. So 4 times 6 plus 6 degrees. 4 times 6 becomes 24. So my final answer is measure of angle JKM equals 30 degrees.